Good afternoon, everyone. Can please someone let me know if the slides are visible?
Yes, ma'am.
I can't hear anyone. Can you type in? Okay. So let us start. So welcome everyone to the live lecture for engineering drawing and computer graphics. So this is live lecture 2 for week 2. This course is being conducted by Professor Rajaram Lakkaraju from IIT Kharagpur, and I am Sanika from Indian Institute of Science, Bangalore. I am a PhD scholar in the Center for Product Design and Manufacturing. So today I will be conducting this live lecture. So, in the last week, you have seen the geometric constructions. So, in this session, we will try to understand the geometry behind the geometric constructions. So, you now know the procedure, but let us discuss why those procedures are correct and how they were developed. So, we can understand the first three constructions through one basic thing: the perpendicular bisector of a line segment, the angle bisector, the arc bisector, and drawing a line perpendicular to a given line. All these three things can be understood by understanding one basic thing. That is by understanding the basic concept of an isosceles triangle. So, most of the constructions are based on the geometric relations in an isosceles triangle. So, what is the property of an isosceles triangle? Two sides of the triangle are equal. So if ABC is the isosceles triangle here, then we have that length AB and length AC are equal. Now, if we want to prove any of the properties of the isosceles triangle, let us draw a perpendicular, which is the most general construction. Let us draw a perpendicular from point A, uh, a line perpendicular AD to the line BC, which is the base of the isosceles triangle. So, from because of this construction, we can prove that triangle ABD is equal to triangle ACD. And how we can do that? We already know that since it is isosceles triangle, AB is equal to AC. In triangle ABD and triangle ACD, the line AD is common. So, in both the triangles, AD line is equal. And we also know that the angle ADC is 90 as well as angle ADB is 90 because AD is perpendicular to BC. So that way we can prove that triangle ABD is equal to angle ACD. So given that these triangles are equal, we have the following properties. We knew that AB and AC are equal and AD is perpendicular to BC. So we can also say that angle BAD, this angle, and angle CAD are equal. What does it mean? Though we constructed a perpendicular line AD to BC, it can also act as the angle bisector of angle BAC. Now, similarly, if you see here, length BD is also equal to length DC. Why? Because again, triangle ABD and triangle ACD are equal. So this length is equal to this length. What does it mean? In an isosceles triangle, if I draw a perpendicular line AD to line BC, it is also bisecting the line BC. So that means that this AD is also acting as the perpendicular bisector to the line BC. And similarly, we can also say that angle ABD, this angle, and angle ACD, they are also equal. So the angles opposite to the sides which are equal are also equal in the isosceles triangle. So now let us see that. So we can see that if we are given any two of the properties, any two of these five properties. So if I am given the five properties that I'm highlighting right now. So if any two of these five properties are given to me, I can prove the other three properties. So that means that if any of these two properties are true, it implies that other three properties are necessarily true. So if we consider the construction of a perpendicular bisector, now we know that AD in the isosceles triangle was the perpendicular bisector of line BC. So what is the procedure that you follow when you draw a perpendicular bisector? You are given a line, let's say, I'll just rename it as same names to emphasize the similarity. So let us say that we are given a line BC which we want to bisect. So if what is the procedure followed? We keep the rounder pointer here and we draw a arc here. Now again with the same radius we keep the rounder pointer here and we draw a arc here. What are we trying to do? We don't have an isosceles triangle here. So what we imagine is BC is the base of the isosceles triangle and we are trying to construct the isosceles triangle by constructing this point which is equidistant from both points B and C. So basically by doing this construction we actually constructed a point similar to A in this triangle. So now if you see this side should be equal to this. I'm sorry for my drawing, but line AB should be equal to line AC. So this point A is on the perpendicular bisector of line BC. But when you actually construct it, the trick is, you can't draw a line from a single point. To define a line, you need two points. So to draw that second point, now you want to construct another isosceles triangle. So you can do that. So you can make these arcs on the opposite side, or there is no such rule. You can make the second set of arcs on the same side. What you need to do is to get 2 points, both of them which lie on the perpendicular bisector of line BC. So this is one point which we got previously, and this is the second point that we got in the second set. And if we join these 2 points, then we get the perpendicular bisector. So now in this perpendicular bisector, what we saw is that the given line is the base of the triangle of the isosceles triangle. Similarly, construction of uh, a arc bisector. So in this also, what is the arc? And please remember that the arc can be bisected only if it is a circular arc. This particular construction is valid only for a circular arc. So consider that this is an arc. I'm sorry. Consider this is an arc BEC. So now again, the endpoints of this arc B and C can be considered as the endpoints of the base of the isosceles triangle BC. So now again when you have this arc BEC, again when you have this arc BEC, you can say that this B and this point C is similar to the base of the isosceles triangle, and then again you try to construct the isosceles triangle by doing the similar construction. You keep the rounder pointer at B, you draw an arc, you keep the rounder pointer at C and you draw another arc. Similarly, to get second point, you can draw a second set of arcs either on the same side or on the opposite side. And when you join these 2 points, or when you join these 2 points, you will get the bisector of that arc. Now, the third construction that you looked at during the week's lecture, which is the angle bisector. Now, again, if we go back to the isosceles triangle, we had seen that if I had drawn a line AD, which was perpendicular to line BC, this line AD was also bisecting this angle BAC. So if you're given an angle like this, let us say this is point O, and you're asked to construct the angle bisector of this angle. Let us say, what should I name them? Let us make this E and F. Okay, so I made these points as E and F. Now, how can we relate this to the isosceles triangle? So now this EOF is similar to this upper portion of the isosceles triangle. But again, we don't have the isosceles triangle here. So when you do the first part of the procedure for doing the angle bisector, what is the first step in constructing an angle bisector? You place your rounder tip at O and you mark 2 points here. So let us name them E1 and F1. So these lines OE1 and OF1 are equal. So now since you didn't have an isosceles triangle, again you went on and constructed sides OE1 and OF1 which can be comparable to sides AB and AC. And now once again, now this E1 and F1 will act as the base of the isosceles triangle which is similar to BC. And then the next procedure that you follow when you draw the angle bisector is, so first you drew these two arcs to mark points E1 F1, and the next thing you do is you place the pointer at points E1 and F1 and draw two arcs with the same radius. So now in this case what happened is you also constructed the base points, and since you already had O, you only had to construct this arc, only one set of arcs to define the line. So you constructed E1 F1, you constructed a set of arcs equidistant from E1 F1. So this was one isosceles triangle that you created, and this was the first isosceles triangle you created. And then when you join the points O and this point, let us say O dash, again this O dash will be uh, acting as the angle bisector of angle EOF. So you can see that only by understanding this simple isosceles triangle geometry, all the three constructions are made simple. Now there is a third construction, uh, which is uh, the construction of a perpendicular line, perpendicular line to a given line from a given point. So what is the scenario here? I will just copy the isosceles triangle figure from the last slide here. Okay, so what is the scenario here? You are given a line, let us say maybe F and G. Okay, and you are asked to draw a line which is perpendicular to line FG passing through point maybe K. So now this K could be outside, or this K or this point, let us name it another point. This point can be maybe M. So again, now again you don't have isosceles triangle here, but you know that if this is a line BC and if I want to draw a perpendicular line to this, I need to construct an isosceles triangle. So now what you do is you again go and somehow create these 2 points B and C. So what we know is this point B and C are equidistant from point A as well as from point D. So I'll just extend this line. So if we, in first case, if we want to draw a perpendicular line from K, okay, so now this K is like the point A. So what I will do is the construction to draw a perpendicular line, what does it say? You place the rounder here and you draw two arcs here. What did we do? We drew two points which are equidistant from this point K. So I'll say this as point 1 and point 2. So now this line 1, 2 is actually the base BC of a isosceles triangle. And then from this point and from this point, you again draw two arcs here and here. So you had one point, and to define the second point, you drew a set of arcs. So this is actually similar to the construction of a perpendicular bisector. So in perpendicular bisector, you were given these points 1 and 2, and you drew two arcs, one below and one above, two set of arcs, one below and one above, which gave you point K, and second one gave you point K2. Now here in the similar condition, it's like you are given the point K, you are given a random line, and you are asked to draw a perpendicular from this point K to this line. So then on your own you generate this point 1 and 2, which is similar to BC, and once you have generated these 2 points B and C, you generate another set of arcs to define the point to draw a line. Now, similar construction if you have a point M which is on the line. So in this case, you want to draw a line that is perpendicular to line FG and passes through point M, which is on the line. Now this point M is similar to this point D. So now again, what does the construction say? From this point M, you draw two arcs. I'll change the color for clarity. Yeah. So from this point M, what you do is you place the rounder here and draw two arcs, one here and one here, which are equidistant. So this point M, and I'll name this as A and this as B. So MA and MB are equal. So now again this A and B, this A and this B are similar to these 2 points B and C. So now again, similar to the perpendicular bisector thing, you have got these 2 points. You mark a set of arcs here to mark one point, and then you mark a second set of arcs here to mark a second point, and then you join this line. So you see just one construction, one isosceles triangle. Once you are given this, once you are given this point, once you are given this line, once you are given this point. So these are all actually iterations of the same problem. You are trying to construct the same isosceles triangle, only the given and to find are different. So I hope you found this interesting. So the next line is dividing a line. So if you are given a line, let's say A, B, and you want to divide this line in, let's say, 5 parts. Mind you, these 5 parts can be randomly done by me, but what I need is 5 equal parts. So that's why we need to do all this construction. So if I want to divide this line AB in 5 equal parts, what does the procedure say? It says draw a arbitrary line starting from point A, let us say a line AD, and with the rounder we mark points 1, 2, 3, 4 and 5. So when we mark these lines 1, 2, 3, 4 and 5, after this we join the last point with the point B, which is the end of line segment AB. And then you are asked to draw parallel lines to this line 5B. This is 2, this is 3, this is 4, and this is 5. So you draw a line joining point 5 and B, and then you draw a set of parallel lines uh, from 4, 3, 2, and 1. So what is the concept behind this? So I'll explain the concept in the next slide. So this is the very basic and interesting concept of similar triangles. So if we have a triangle here like this is triangle A, B and triangle C. And I have a similar triangle, a bigger triangle, let's say D, E and F. Please excuse me for the figures, but just understand that AB, uh, that angle BAC is equal to angle EDF, angle ABC is equal to angle DEF, and angle ACB, this angle, is equal to angle DFE. So, what does this tell us? From this, we can say that um, the sides AB and AC, if we take the ratio of the sides, it is equal to DE by DF. So this comes from the similarity of triangles, that if the triangles are similar, we have that the ratio of sides AB is to AC is equal to side DE is to DF. Similarly, we will have AB is to BC, AB is to BC is equal to DE is to EF, and similarly we have BC is to AC equal to EF is to DF. So if from this equation, this particular equation, I say that length AB is equal to small c, let us say C1 and C2 for this, B1 and B2 for this. So these are actually lengths, like it might be some 10 centimeter, 5 centimeter or something like that. And this is A1 and this is length A2. So these lengths are actually in ratio. So if I say that I know that C1 by B1 is equal to C2 by B2. Okay. So now if I want C2 minus, so if I just rearrange this, I will get C2 by, I'm sorry, just a second. So if I rearrange this, I'll get C2 by C1. So I'm bringing this down here and I'll get this B2 here is equal to B2 by B1. And now if I subtract minus 1 and minus 1 from both sides, what I'll have is C2 minus C1 by C1 is equal to B2 minus B1 by B1. Okay. So what did I do? This is simple algebra. I just made a common denominator. So this 1 can be written also as C1 by C1 and this 1 can be written as B1 by B1 and I subtracted them. So why am I doing this? So let us say that I superimpose this smaller triangle on this triangle. So I'll delete a few sketches that I've made so that it is clearer. Okay, so I will just pick up this triangle and I'll place it over this one. Okay, so now the line AB was C1. I'll write it on the inside. So line AB was C1, line AC was B1, and line BC was A1. Okay, so after doing this, what I have is C2 minus C1, that is the length BE here. So from AE is C2 and AB is C1. So C2 minus C1 is this line BE. Similarly, here AF is B2 and this line uh, this line is B1. So B2 minus B1 is actually this length. So what is this ratio? This ratio is of this ratio that I'm talking about is of this length C1 by this length C2 is equal to this length B1 upon this length, which is B2 minus B1. So you can see that if I can construct some more similar triangles, like if this was ABC, I can also have a triangle similar to this, like this. So in that case also I can have, I'll choose one more color here. I can have that from here to here, this was side of triangle ABC. Here to here was the remaining side of the new triangle. From here to here is the third triangle. So like here I proved that this line by this line is equal to this line by this line. I can also prove this for multiple triangles. So when we come here, this is one similar triangle, this is another similar triangle, this is the third similar triangle, and this is the fourth similar triangle, and so on. So that is how this dividing a line concept of drawing a line AD, marking 5 equal points on our own, and then drawing these parallel lines also divides this line AB in equal parts. So here from similar triangles we can prove that A1, I'll mark this as consider this as um maybe point 6, 7, 8 and 9. So I can say that uh, A1 by A2, A1 by 1 2 is equal to A6 by 6 7. I can say that uh, 1 2 by 1 3 is equal to 6 7 by 7 8. Now line A1 by 1 2 is equal to A6 by so I'm sorry, A6 by A6 by 6 7. Now I know that this segment A1 and segment A2 is actually equal because I have drawn these points 1, 2, 3, 4, 5 by keeping the distance in the rounder similar. So I know that this ratio A1 by A2 is equal to 1. And similarly then I get that A6 by 6 7 is also equal to 1. So that says that A6 and 6 7 are equal parts. And similarly we can have multiple parts of AB. So you can actually bisect the line by this method also. So instead of drawing 5 points, if you draw from this point, if you draw only two marks like this and name them as 1 and 2, and this is your line AB which you wanted to bisect, then you draw a line joining point 2 and point B, and then second line like this. So even this construction will divide your line AB into equal parts. But this point will give you just the center of this line, but this will not be a perpendicular bisector. Okay, so can you guys share if you understood what I was trying to explain? You can put it in the chat box. Or if you have any questions from the lecture, maybe you didn't understand one of the construction, or if you just want to discuss some construction that you uh, did, you can open up your mics and speak up. We can have a small discussion if you want. Anyone? Okay, just list down the different constructions that you learned in the last week's lecture. Should I call out names? I don't think there are many people, so I'm talking to only two or three of you whom I can see. Okay, so that's it from my side. Do you want me to discuss any other construction? Okay, so if there are no one is speaking, so I assume that you don't have anything to discuss. So shall we close this meeting then?